All right, now we get a real deal one. We talked about techniques, and we got just finished up talking about factoring. You got a problem here that is going to involve factoring. So we have sine of x plus sine of x times tangent of x equals 0. Now the idea is do not factor until it is equal to 0. If it is not equal to 0, your factoring skills will be all in vain. It will not do anything for you. So I did you a solid. I got this thing set equal to 0, so we're starting off really nice here. So if you look at the left side here, sine of x plus sine of x tan of x, we notice the GCF is sine of x. So we're simply going to factor out the sine of x. That would leave us with 1 plus tangent of x equals 0. Now the idea is when you factor a quadratic equation, this is not quadratic, but when you factor a quadratic equation, you would set each factor equal to 0. So we have two things. They are officially sine of x and 1 plus tangent of x. They are multiplying to be 0, which means either one could be 0. So set each factor equal to 0. Sine of x could be 0, or 1 plus tangent of x could be 0. Now, the first one, if we're looking for principal values, you're just going to do the sine inverse of 0. And the sine inverse of 0 is, well, 0 degrees if that's what you're talking. I was not specific about my directions because I want to do everything. So principal value is 0 degrees or 0 radians. Let's put that like that. Okay, if we go between 0 and 360, 0 less than or equal to x less than or equal to 360. Well, we saw in a previous video, we're talking quadrantals here. 0 is a legitimate answer from 0 to 360, so our principal value is good. Where else does sine hit the x-axis when you graph it from 0 to, well, we normally did 2 pi, if you recall. Well, it's also going to hit the x-axis at 180 and at 360. And all three of those will be solutions for this part. Right? Then we go to 0 to 2 pi if they were to ask that. So remember, put that. 0 to 2 pi, well, 0 degrees is 0 radians, 180 is pi, 360 is 2 pi. Also, pay very careful attention to whether they say equal to or not, just on the quadrantals, because that's where you would have to worry about it. All right, going to this guy. Well, 1 plus tangent of x equals 0, that kind of goes back to our isolate, if possible. Well, we can now isolate the tangent of x, meaning subtract 1 from both sides. So now we have tangent of x is equal to -1. Do our inverse tangent for the principal value. So the inverse of -1, also I think vaguely familiar, that should be -45 or -pi4. Remember, that's going to throw you into quadrant 4, the inverse function will for tangent. Does the same thing for inverse sine if it's negative. All right? Then we go 0 to 360. So 0 less than or equal to x, less than or equal to 360. Well, -45 is no good, obviously, so we got to look. We've already done this one. Seems familiar. So we're talking about a reference of 45 in quadrant 4. We're talking about 315 would be the usable angle. So 315. And where else is tangent negative besides quadrant 4? Well, quadrant 2 with a reference of 45. You're looking at 135. Yeah, we did this one. All right, so in terms of radians, let's finish it off. So 0 less than or equal to x, less than or equal to 2 pi. Hoping you can see that down there. Yeah, you can actually see that pretty well. All right, so what are we looking at? We're looking at 315, which is 7 pi4, and 135, which is 3 pi4. So what do I say are my solutions? Well, if you're talking principal values, I guess I should have put braces around these. That was not a very solid effort. We can do better than that. Professional. Negative 45, negative pi force, 0, 0. So I guess summing it up, principal values, if they said solve this equation for principal values, you would say, well, my solutions are 0 degrees and negative 45 degrees. If they wanted degrees. If they wanted radians, well, you give them radians. 0 radians or negative pi force radians. What if they say solve between 0 and 360? Well, you got to give them solutions between 0 and 360, which would be several. 0, 180, 360. 180, 360 to be joined with 315 and 135. 315 and 135. 5 solutions for this between 0 and 360. And of course, what if they say 0 to 2 pi? Well, then you say, okay, we got 0 radians, we got pi radians, we got 2 pi. 315 is 7 pi force, and 135 is, should be able to fit that in, 3 pi force right at the edge. And thus we have solved our first one where we had to actually legitimately factor. All right, try a second. Again, I'll just say solve. We'll keep it generic, so I want to do all the solution types. Okay, this one looks good. We got 2 sine squared x plus 2 sine of x equals the sine of x plus 1. Yikes. All right, well, if we wish to solve this one, the idea is you're not going to be able to isolate a sine. If you got a sine squared and a sine in the same problem, forget the idea about just isolating that. But what we can do is, let's get this thing set equal to 0, see what happens. So if I get this set equal to 0, I am literally subtracting sine of x from both sides. This is totally illegal when you're verifying. But we're not verifying. This is not an identity. We're solving, so we're treating it just like an equation. And while I'm at it, I am going to subtract 1 from both sides, just so this is equal to 0. So in order, I would write 2 sine squared x. 2 sine of x minus sine of x is plus sine of x. And then minus 1 equals 0. Now the question is, what do I do with that? Well, we're going to attempt to factor it, because we're going to think of this as 2x squared plus x minus 1 equals 0. Think of it as being very similar to that quadratic equation. Well, this quadratic equation does factor. How? Well, it'd be a 2x and an x, a 1 and a 1. Outer, we'd need a positive. Inner, we would need a minus to get a positive x, yeah. And then we would just set our factors equal to 0. The idea is, well, the one above it should be pretty similar. Just replace your x's with sine of x. All right. Let's see what we get here. So replacing our x's with sine of x's, we can factor that as we would a normal, quadratic trinomial there. We would get 2 sine of x minus 1 sine of x plus 1. Now the whole point of factoring, keep in mind, is to set each factor equal to 0. So now we have 2 sine of x minus 1 equals 0, or sine of x plus 1 equals 0. We just have to solve those two equations. So solving the first one, we're going to add 1, divide by 2. We're isolating now. So bottom line is sine of x equals a half. Over here, minus, well, sine of x equals negative 1. Okay, job 1, let's go to principal value. We're going with principal value. We're doing the inverse sine of a half. Literally, what is the functional inverse sine of 1/2? The answer is 30 degrees. Or, if you're talking radians, looking at pi 6. If we do principal value over here, talking sine inverse of -1, going to probably have to go to our graph. This is quadrantal, but we will get negative 90 degrees or negative pi halves. I can fit that in, I think. Right? And, these are our principal value solutions. So if they said solve this for principal values and give it in degrees, I would answer 30 degrees, negative 90. If they said solve for principal values, give radians, I would say pi 6 and negative pi halves. All right, 0 to 360. They say solve between 0 and 360. Well, we're going to use our principal value. In this case, our principal value is actually one of our solutions, which is just super. Not always, but at the very least, it gives you a strong clue how you're going to finish this off. So 30 degrees, we just now have to ask, where else is sine? Go back up to this. Don't go to the inverse. Where else is sine positive besides, quadrant 1, that 30-degree angle? And the answer is quadrant 2. Reference 30, actual angle, we're looking at 150. Right, and then just simple matter, if they said, okay, well, this time we want radians, well, give them radians, that is pi 6, 5 pi 6. All right, over here, we got a principal value of negative 90. Whoops, we'll finish this. We got a principal value of negative 90 if we go from 0 to 360. I think we've seen this one before. There is only one place. Now, negative 90 is no good here. It's less than 0. So we have to go the long way around. So not negative 90, no good. You got to go the long way around, which is 270 degrees. So 270, or radians, would be 3 pi halves. Starting to get lazy here. 3 pi halves. And then the other solution, is there anywhere else where sine of x is -1? And the answer is no. Graph sine out, and there's only one place where sine is at -1, from 0 to 2 pi. So how do I say my solutions? Well, there you go. Let's hurry up on this one. Principal values, we would say, well, we got 30, and we got -90. That's if they ask for degrees. If they ask for radians, we would say pi 6, negative pi halves. They said 0 to 360. We would say, okay, 30 is good, and so is 150, along with 270. 270, there we are. 270. They said, no, radians. Radians. Well, then we go with pi 6, we go with 5 pi 6, and we go with 3 pi halves. Those are our solutions. Final answers.